Assalamualaikum and good day to everyone. So my name is Fikri. I'm from School of Mechanical Engineering, Faculty of Engineering, Universiti Teknologi Malaysia, Johor Bahru. I would like to present about review of internal resistance and temperature relationship, state of health, thermal runaway for lithium-ion battery beyond normal operating condition. Without further ado, let's continue. A little bit of introduction. There are two types of batteries. The first type is non-rechargeable, and the second type is rechargeable battery. In non-rechargeable battery, they are normally made from zinc carbon and alkaline. And for rechargeable battery, we have lead acid, nickel cadmium, and lithium-ion battery. The picture shown on the left is a lead acid battery, and the middle is nickel cadmium, and the right is a lithium-ion battery. So my research was about lithium-ion battery, so we're gonna focus more on lithium-ion battery on this presentation. Continuing about lithium-ion battery, it is a popular energy storage method because it has high power density and low self-discharge. And a normal operating temperature for lithium-ion battery is 40 degrees Celsius until 65 degrees Celsius. So, but lithium-ion battery can be damaged by internal short circuiting, or overheating, or overcharge voltage, or charging after over discharge. This is dangerous because the hazard of battery thermal run, the lithium-ion battery can pose a hazard of battery thermal runaway, which is a serious issue because it could cause burn injuries to consumer. And most of the time, designs that uses a lithium-ion battery as power source will try to avoid and prevent the battery from operating at high temperature. But there are also some unavoidable cases that requires the LIB to be used at high temperature. So we're going to see what kind of situation that uses lithium-ion battery. Okay, these are 5 examples where lithium-ion battery is used at high temperature. The first example is on medical field, where wireless devices such as cordless drill used in operating theater use battery as power source, need to be sterilized above 400 degrees Celsius. Also oil and gas sector, where logging equipment is used far below the earth surface, where tremendous pressure and temperature conditions exist. And furthermore, for military use, for surveillance and monitoring, where device that is sent out, such as drones, will be operated at high ambient temperature. In electric motorsport, Formula E uses high discharging rate to get a lot of power to supply to the motors. This will cause significant increase in lithium-ion battery temperature. And in recent studies carried out by Zhou Guangyang et al., they proposed a novel method of extreme fast charging by elevating the battery temperature to 60 degrees Celsius periodically. They are able to retain 91.7% battery capacity for 2,500 cycles of 10-minute extreme fast charging. 10-minute charging is quite fast for a large battery pack. Moving on, and we have custom cells batteries. Custom Cell is a company that made custom battery especially for high temperature usage. So the picture on the right is the battery that they produce, and on the left there is a graph restore capacity versus temperature. As you can see on the blue line, at 75 degrees Celsius constant current high temperature battery usage, the battery performs 500 cycles with more than 0.8% normalized 0.8 normalized capacity, while the standard lithium-ion nowadays only perform 200 cycles with 0.2 normalized capacity left, and the difference is quite big for a battery made by custom cell and the standard lithium-ion battery. Okay, we're moving on to the next topic, which is internal resistance and temperature. Okay, in lithium-ion battery, the internal resistance occurs due to resistivity of the component material and an ionic component due to electrochemical factors such as electrolyte conductivity, ion mobility, and electrode surface area. In layman terms, when the movement of electrons are obstructed along the circuit path, it is subjected under a certain amount of resistance. So in battery, we call it internal resistance. And there are several methods in identifying internal resistance, such as VDA current step method, ISO current step method, current off method, switching current method, AC internal resistance, impedance spectroscopy, energy loss method, and quasi-adiabatic calorimeter. Okay, so there are two graphs that I'm presenting here. So the left graph was a study conducted by Epkowski in 2011. So he made the internal resistance against temperature, where he plotted a varying temperature from negative 30 Celsius to 55 Celsius. Noted that internal resistance is high at cold temperature at negative 30 and drops very low at high temperature, 55 degrees Celsius. And on the right is a study conducted by Low in 2012. So they have a similar pattern. Okay, it is evidently clear that lithium-ion battery internal resistance trend line decreases almost exponentially as the battery temperature increases. That is true for lithium-ion battery normal operating temperature range, but most studies stop below or at ideal lithium-ion battery operating temperature. If you look at the graph, they only conducted the research until about 50 or 55 temperature range. There are less study that continue the temperature. If the trend line continue to decline even in high temperature region, thus logically it is more beneficial to use lithium-ion battery at high temperature because of low internal resistance properties. But using battery at high temperature also have a downside. The downside is on impact on the state of health. So next topic is internal resistance and state of health. Battery state of health is used to indicate on how much battery has degraded. Degraded battery can be distinguished into decrease in battery capacity and increase in internal resistance. So there are three causes for battery degradation mechanism, which are chemical, mechanical, thermal, and all of it depends strongly on electrodes composition. Furthermore, battery can be considered has reached its end of life, EOL, when its capacity has dropped to 80% from its original state. So like I said before, using battery at high temperature also can have an advantage, which is low internal resistance, but also have a downside, which leads to faster degradation. And this graph conducted by Ramlinger in 2011. So you can see the comparison between a new cell and degraded cell. A degraded cell has higher internal resistance. Moving on to the next topic, thermal runaway. In essence, thermal runaway is a process where energy is released at higher rates, which causes rapid temperature rise. Thermal runaway behavior has three distinguishable stages. There are other studies that put the thermal runaway in 4 and 5 stages, but for me, I personally prefer 3 stages. The first stage is where the battery is swollen because of gas and heat accumulate in the battery without any presence of flame. The second stage is when manifestation of bright flame, material jetting, and gas venting occur. The battery temperature may reach hundreds of degrees Celsius at this stage. This gas venting from the battery consists of hydrocarbons, CO2, CO, and H2. And finally, the third stage is when the flame around the battery gradually reduces and finally extinguishes. Okay, the picture shown about stages for thermal runaway. Stage 1, Stage 2, Stage 3. There are two rows. The first row heating by cylindrical heater, electrical cylindrical heater, and the bottom row is furnace. This research conducted by Wang in 2019. As you can see, the first stage, the majority of the picture is there's no flame, only battery bulging. Second stage, vigorous flame and material jetting happens, and finally continue to third stage where the flame extinguish. This is a temperature graph for the thermal runaway, and as you can see, the first stage, the temperature rise slowly and it continue to rise until about 200 degrees Celsius, and then suddenly second stage takes over, and it's happened very rapidly, reach temperature up to 700 and more degrees Celsius, and after that gradually decrease because the third stage comes and the flames start to extinguish, temperature continue to drop until room temperature. Okay, so conclusion is lithium-ion battery is generally used as energy source in temperature range between 40 degree to 65 degrees Celsius for ideal usage. But there are also unavoidable situations where lithium-ion battery needs to be used beyond the ideal normal temperature. Because of that, battery manufacturer has conducted research and development to produce high-temperature lithium-ion battery to fill in the demands. And in addition, using lithium-ion battery in high temperature also brings advantage. This is due to decrease of internal resistance when the battery temperature is high, allowing more performance to be extracted from the battery. But the downside of using lithium-ion battery at high temperature is that it will degrade faster and cannot be used for long lasting. And on the other hand, using lithium-ion battery at extreme temperature can induce thermal runaway, which is the situation where battery destroys itself. And thank you for hearing my presentation. But before that, I would like to thanks Ministry of Higher Education for sponsoring this research. That's all from me. Thank you.